I want to talk a little bit about probability today. And then once we are done with probability, then probably we can do an exercise if we have time. Okay. All right, it's half an hour. Do we need to stretch a little bit so that you guys get ready to learn some new things? Okay, let's stretch. Okay. 5 seconds stretching. Okay. All right, good. All right. So before we get into the idea of econometrics, we are going to go over probability and statistics, some of the things you already learned before. So I want to use some very useful examples to give you an idea about what we're getting into. So you learn about probability when you watch chapter 2's YouTube video, but here is an example. And even if you haven't watched it, you can still just try to get into it before you watch it, okay? All right. Okay. So probability in the case of climate change, the reason why I chose this climate change topic is I personally feel very passionate about the idea of climate change, okay? We all know that climate is changing, and the whole world is having a lot of difficulty, okay? And a lot of my research projects is also on the economics of climate change. So I personally just feel excited to talk about this project. So before we get into it, let me see how much of you know these things, okay? So this year, the United Nations published a report on climate change, and some news have reported it because it's not good. Okay, so one of the takeaway is that the world has already warmed up. Okay, we already experienced a warmer world than our great-grandfather. Okay, so how much have that warmed up since the 19th century? Okay, how much degrees Celsius or how much degree Fahrenheit? Okay, does anyone know about it? Put it in the chat. 3, 10, 1.8, 1, 2, 5. Oh wow, that's a huge variation. Okay. Wow. You guys, some of you are pessimistic. Okay, so the climate science, okay. Yes. Okay, some of you. So the climate science uses degrees Celsius as a standard unit, but in the United States, people use Fahrenheit. So it's about 2. Okay, so the world already warmed up about 1.1 degrees Celsius. Where can we read chapter 1? Oh my gosh. We need to buy ebook or we will see all chapters in Pearson. Yes. Okay. Did you just ask me to repeat what I have just said in the past half an hour? Which is get Pearson or watch the chapter 1 video. Okay. All right. So next, we are locked into how many years of worsening climate impacts no matter what the world does. Wow. 100. Okay. Okay, that's also a lot of pessimism. 1,000. Oh my gosh. I don't think science can predict anything within 1,000 years. Okay. All right. So this a lot of you are right. We're locked into 30 years of worsening climates. Okay. We're locked into 30 years of warmer climates for sure. And this 30 years will be the most important 30 years of my career, and I think it will be yours as well. Not sure if it will be Kanye's. Okay. And then the last question is it's not related to this UN report, but what's this current president's goal? Okay, so Biden's goal of achieving a carbon pollution-free power sector by which year? And a net zero emission economy by no later than which year? 2030, 2050, 2030. Okay. I feel like some of you are good. Okay. All right. Okay, so a carbon pollution free power sector means that by 2035, which by that year I'll be 40-ish year old. Okay. Oh, all right. At that time, all the power that we use, okay. By that time, all the power that we use in this country will be generated by non-fossil fuel, or even if it's from fossil fuel, it will all the pollution, all the carbon emission will be captured by carbon capture technology or some other things, fancy thing. Okay. And then by 2050, we'll get a net zero emission economy. So net zero doesn't mean that there is no emission. It just means that all the emission will be offset by planting trees or carbon capture technology. Okay. Does anyone know what's China's net zero goal? Or you think that will happen? Yes, I do. Um, I do think that would happen. Okay. But it depends on a lot of different things. But that's the only way to do because the next few years will be terrible. What's China's net zero goal? When is China's net zero goal? China is the biggest emitter, right? So it doesn't make sense if we don't care about when China is getting net zero. 2060, correct? Yes. China last year, China pledged the net zero goal by 2060. So my internet connection is not stable. Does everyone hear me? Okay, good. Yes, okay, good. All right. So the thing is, I sometimes would tell my mom that by the time when net zero is reached, she might still be alive and she doesn't know what I'm talking about. But for sure, we're gonna be still alive. Okay. All right. So we are doomed for sure, and things are gonna get worse before it gets better. Um, we're we're for sure getting a warmer weather, but do we know if we are getting a wetter or drier weather? That's the next question. Do you think we're getting a drier or wetter weather in North America? Depends on where. That's correct. Okay. Yes, that's correct. And the answer is it depends on where you live. So this is a simulation of a change in precipitation if we have a 4-degree global warming. So the brown areas will be drier, but the green area will be wetter. And some places are already wet, will be wetter, right? I'm talking about India. Okay. India already get a lot of water in the summer, but now they're gonna get more. How about America? If we zoom in here, we're getting more precipitation for sure. And then here we're getting more, but right here, in the middle might get drier. Okay, so we know that it feels like this place is relatively not so dark in any color, but the problem is this is just an average simulation. Some places might have a whole day. Some places might have a whole years of rain in one single day, right? So that could still happen. Um, most of the drier parts are over the ocean. Uh, that is true, right? That is true, except for I think this part is getting drier. Um, okay. This is just a simulation, but this is what we're gonna expect. Okay. All right. So, how do you know that? The question is, we don't know yet. Okay, but climate science is getting better. Okay. So in 2100, when all of us are around 100-year old, I'm gonna be above 100-year old. Probably not alive anymore, but some of you might be alive. Okay. Given that the life expectancy is increasing over years. So in 2100, the world is gonna spin one of these lottery or gambling. Okay. And if we spin the first one, which is if we don't have any policy to work together to reach a better to reach a climate goal or something like that, then we end up with something that's called no Paris scenario. Okay, you can see that it's all orange, red, or purple. Okay, it's scary. If we have Paris Agreement for forever, then it will be this second one in the right, upper right corner. This one is more orange, but still scary. And down below will be a 1.5-degree policy and 2-degree policy. So 1.5 or 2. If you're American, you can think of this as 3-degree to 4-degree policy in terms of Fahrenheit. Um, it will look a little bit better, but these colors are still increasing temperature. Okay, it's not they are not like we're gonna get decreasing temperature, and the problem is we already warmed up 1.1 degrees. Okay, all right. So when am I gonna talk about probabilities? Next. Okay, so I think pie chart is one of the most intuitive way to talk about probability because we probability in total is 100%, which is the whole circle, right? And then all the different pies add up to one circle, which means that all the probability will add up to one, okay, or 100%, okay? And the different shape of them represent what's the chance of, if you spin an arrow, what's the chance of that arrow landing in that area? Okay, so pie chart is a good chart when we talk about probability. Okay, so let's do a small exercise. What is the probability for 2100 if we have an at least several degree increase in temperature? Okay. So for example, at least 1.5 degree means that in 2100 we'll have at least 1.5 or more temperature increase than today. 100%, 100 or 0? It's 100. Okay. Okay, that's correct. It's 100% because I'm not talking about exactly 1.5 degree. Okay, I'm not talking about exactly 1.5 degree increase. I'm talking about at least 1.5 degree increase, right? But if you look at this spin, you realize that if we don't have a coordinated global efforts, we don't even have that scenario, right? Because the smallest number is 2 to 3 degree. Okay, so that is correct. If we don't do anything, we end up having we will have 100% that our world will be 1.5 degree, at least 1.5 degree hotter than today. Okay, how about 2 degree? Or at least 2 degree? Think about it. Is it 14 or still 100? Asahi raised hand.
Still going to be 100.
Still be
Because
100.
it's at least 2%.
At least 2%, at least 2 degrees. Okay, that's correct.
Sorry, yeah, 2 degrees.
Yes, that's correct. Okay, so that's correct because the smallest bin here is between 2 and 3. So if I'm asking, will we have at least 2 degree? Then the answer is absolutely yes. If there is no Paris Agreement or if there is no global coordination or efforts. Okay, how about 3%? Sorry, 3 degrees.
86%.
86. 86 plus 14. Oh, everyone says 86. Okay, good. All right, seems like everyone now know how to play this game. Good. All right, so if we spin this thing, if there is no global efforts and okay, if there's no global efforts, then we spin this, and so we will at least get 3 degree. Then the chance that in 2100, at least 3 degree increase will be 86%, correct. How about 3.5? Think about where 3.5 is. 3.5 is here. Okay. Okay. So if it's a 3.5, how do we approach this question? Then we have to add up which pies. We have to add up all of these 3 pies, right? Do we know all of these 3 pies? We don't. Okay. So how do we do it?
You would add up the other side and just subtract it from 100.
That's correct. Okay. All right. Okay, 100 minus 14 minus 14 minus 20, right? Okay, how much is this?
52% or 52 degrees.
52%. Okay,
Sorry, yeah.
correct. Okay. All right, how about 4 degree? 4 degree. 4 degree, which one are we looking at? This one, the most purple one. Okay, so 4 degree is simple. It will be 14%. Okay. Okay, so let me explain what does 4 degree means. Even though for some of you, you think, oh, 4 degree is fine, right? No, the thing is, 4 degree means when did we have 4 degree before? This is a question. So when we have dinosaurs, it was 4 degrees higher. And when was that? That was 66 million years ago when we have 4 degrees higher, and our Arctic has crocodiles and dinosaurs and have no ice. Okay, that's 4 degrees. That's only 4 degrees higher than today. Okay. How about ice age? Um, Ice age is some billion years ago, and ice age is only 6 to 8 degrees colder than today on average. So even though 4%, oh, sorry, even though 14% is looks like a small chance, but it still might happen. And are we able to survive even though we're not dinosaurs? We don't know, which means that we need a Paris Agreement, right? Okay. Okay, scary stories is over. Let's talk about probability. You mean at 4 we will burn? I don't think so. I mean, dinosaurs can't be alive. Maybe we could, right? Okay. I think so. I think this is a scenario we will not experience. I think there will be a global effort in it. I believe in it, okay, because I still believe that this world can do something good. But some people might not believe it, so we don't know. Okay, let's talk about probability. Okay, not talk about dinosaur. We don't have dinosaur anymore, even though I think dinosaur is interesting. Okay, let's talk about probability. Okay, um, this is the exercise that we just did. Okay, if we don't have Paris Agreement, what's the chance of 1.5 degree? At least 1.5 degree, 100%. At least 2 degree, 100%. At least 2.5, 99%. Okay, that's already very scary. At least 3 degree, 86%. Okay, this is what we just did. Okay, so let's answer the first question. What's the probability of 2 degree rise, or at least 2 degree rise, given that there are no Paris Agreement? 100% correct. Okay, because we're just looking at what we are looking at right now is, okay, if you don't know what's this sign, if you don't know what is this sign, this is a condition, okay? If you don't remember it, you should probably spend some time on probability. So at least 2 degree rise conditional on no Paris Agreement, then we should look into this probability. Oh, this color is weird. Okay, then this is what we should look at, which is 100%. Okay, how about conditional on a Paris Agreement? Still 100% correct. Okay, so if there is Paris Agreement, we're looking at this one, right? So it would still be 100%. Okay, so now the question is, are 2 degree rise and Paris Agreement independent event? What do we mean independent? Let's see, does anyone remember independent events definition? Okay, suppose you have 2 alarms. Your iPhone has an alarm, your Alexa has an alarm. I hope I didn't trigger that. Okay, good.
I
Are they
think,
independent? And the answer is yes.
Is 2 independent means one does not affect the other?
One does not affect the other, that's correct, which means that you have 2 different alarms and they don't affect each other. Okay, one broke would not affect the other one, broke or not. Okay. Okay. So some of you says, yeah, yes. Okay. All right. So yes, it is independent, correct? Because no matter you have Paris Agreement or you don't have Paris Agreement, 2 degree, the chance of 2 degree rise is the same. Okay. Think of this as no matter your another alarm works or not, the chance of this alarm work or not is not going to change, right? Because two machines work independently. So here it's the same. No matter we have Paris Agreement or not, we are for sure getting a 2-degree rise, which is halfway towards a dinosaur. Okay. So yes, they are independent. Okay, they don't affect each other. Okay, so then let's continue. What's the probability of at least a 3% rise conditional on no Paris Agreement? Okay, we should look at this one, right? Okay, so it's 86%, that's right. How about with Paris Agreement? Okay, it's different now. Okay, it's 59%. All right, so are 3-degree rise and Paris Agreement independent? Okay, no. Okay, they are dependent. Dependent. All right, correct. No, they're not. They're not independent, or they're dependent, because when you change the condition, the probability of 3-degree rise change. Okay, that means that for 3-degree rise, our actions still matter. Okay, whether we have Paris Agreement or not still matters. Okay. Oh, this is scary. Which means that Paris Agreement is not enough for us to survive, I think. Um, I don't really know what Paris Agreement right now its policy is, but I think all the countries, including the Europe, or all the countries are making new goals, which may be better than with just a Paris Agreement. Remember when in the first slide, in the spin, right? We still have a 1.5-degree policy and a 2-degree policy. So my hope is we can get to the lower two, but we don't know. Okay. All right. So that's probability, a conditional probability. Now everyone should understand two things. One is what is conditional probability. Second is when are two events independent? Okay. If two events are independent, then it means if you put one event into the condition of the other, the probability of the other is not going to change. Is that clear? That means that if you put a condition, it's not going to change its probability. Okay, good. All right. So next page, what's next? Oh, the most challenging part of probability. Okay, that's basically it. First, how do you calculate conditional probability? If you need to calculate probability of A conditional on B, you divide the center part, which is the overlapping part, by the one that is the condition. Okay. This is my favorite way of helping you to remember. But since you are at home, you have cheat. You can look up. Okay, I don't want to say you can cheat, but that's how you remember it. It's like you divide the overlapping part by the condition, which is B. B is the condition. A is the event. Okay.
Jump over here. Yeah, he's fine. He passes the 5.
Oh, okay, good. The second is independence. Independence means that even you add a condition of it, the probability is not going to change. So I have two ways of defining it. The first way is probability of A conditional on B still equals to A. okay, which is the first one, or probability of B conditional on A still equals probability of B. Okay. All right. This is the most challenging part. The equation might look unfamiliar to you. What you need to do is just get familiar with it. Okay. The story is just that simple. Does that condition change its probability? If it changes, then they are not dependent. Sorry. If it changes, then they're dependent. If it doesn't change, then they're independent. Okay. All right. Online teaching.
Oh, let's go. Let's fucking go.
Okay. All right. Online teaching. Somebody message him privately. Okay. All right. Let's see. One last page to wrap up this part. Oh, it's the space bar. Okay. Do you mute yourself if you press space? No.
Yes.
Well, but I pressed it and you guys still hear me, right? Okay. I don't know. Oh, I unmute myself.
If you hold it, yeah.
Okay. Oh, okay. All right, you guys, be careful. Just don't embarrass yourself, okay? I mean, I'm fine. Okay, next. Okay, so the last page is not really about probability, but about what's the probability of Paris Agreement? The question is, do we for sure getting a Paris Agreement or something better than that? And the answer is no, because just the last president, which just the last president had different idea, right? He withdrew from the Paris Agreement, and Paris Agreement, even though other countries stays in, but Paris Agreement requires all the countries to sit down together, figure out ways to figure out these things. Eventually, we will have a global carbon price, because if carbon price only exists in one country, it's not going to work. Okay, or it's not going to work as well as a global carbon price. So eventually we'll have a global carbon price, and that requires all the big players to sit down together. And so what's the probability of Paris Agreement? It's not a statistic question.
Oh, yeah, right.
Oh my gosh. Okay, if he unmute again, we're gonna remove him. Okay. So this is not really a probability question, but a probability question combined with political question, right? Because we think about when people are talking about we're thinking about people when people are voting for different politicians, candidates, how much do people care about climate? And the thing is, if half of the country doesn't care about the climate, then you still get 50% chance that next term there will be a new candidate who think differently. So does that mean the probability of...
What was the plan then?
Okay. All right. So does that mean that, let me see. Okay. All right. Okay, let's remove him first. Okay. So I just want to finish this last page. The thing about Paris Agreement is a political question, And most of the things you learn in this class has a correct answer, right? Most of the things you learn in this class has a correct answer, but most of the questions you come up with in your life and in your career are questions like this that does not have an answer over there, doesn't have a correct answer over there, and you have to navigate over that. And that doesn't mean what you learn is not useful. So for example, if in the future, the younger generation care more about climate and they would come into the voters, right? They grow up, they become voters. The older generations doesn't care that much because they're not going to be alive when it's so hot. They're not going to be alive anymore. So they don't care that much, but they would die and they can't vote anymore. So maybe in the future we will have more people who care about climate and will vote candidates who care about climate. And then at that time, you use conditional probability to calculate, oh, this generation, conditional on different generation, what's the probability of how much they care about climate as what kind of candidates they vote. Okay, so the last question is for you to think about. Okay. All right. Online teaching is difficult. Online learning is difficult. I understand. Okay. So in the future, if this happens again, I probably will remove you. Okay. And then you'll probably embarrass yourself a little bit, but I won't do anything yet. Okay. All right. Some more questions, concerns? Oh, okay. So Darius asked me this question. Do I accept? Oh, okay. So Darius asked this question that do I accept question within a certain range? The answer is Pearson would decide that. So for example, 1.11 and 1.10 probably will both be correct. That depends on what Pearson decides. So we'll do exercise together and we'll come up with that. Ryan asked what will be the format for midterm and final. Midterm and final will look like a combination of a quiz and homework, and they will be on Pearson, but they will have a set time. Okay, so I would say, okay, from 7 to 9 p.m. You have to do it within this time frame. Do you have any examples on YouTube? The question will have in quizzes and midterm. I don't have anything on YouTube that is on examples, but we'll go through those in our Tuesday sessions. Okay. So Thursday sessions will be drier theory, but Tuesdays, so today we have an example, but in the future we'll have examples on your homework, let's say. Moise, is that how I say your name? All right, online teaching is difficult. Good. What else? What will be the format? Oh, I already answered this question. What are the questions that I did not answer? Okay, too many messages. All right. Then I guess we are done.
Do we have access to this recording?
Do you have access to this recording? Yes.
Yeah, because I need to go over probability because it's
okay, yes, you have.
Not in years. Okay.
Professor, this is regarding the question I asked before, but when I meant a range, it was a question like, so say for instance, if the answer is 1.09 and the
Oh, 1.09 or 1.08. Like, okay, I think so Pearson would say round it to a certain decimal places, and then probably in the last space, there would be a +1 or -1 range. But I think once you get to practice on Pearson, you realize that because Pearson would tell you if that one is right or wrong. Okay.
Yeah, I got it. Thank you so much.
Okay, good. All right. This recording will be funny. Okay, all right, that's it. I wish everyone good night tonight, and I will see you guys on the 14th.
Okay, good
On the
night.
14th. Okay. All right, good night. Don't forget
Thank you,
quiz 1
Professor.
and homework 1. Bye.
Bye.
Night.
Thank you.
Good night. Bye.